Today's topic is motion and force. Force interaction between two objects that causes a change in the motion of the objects. What impact can forces have on objects? Make it move, make it speed up, make it slow down, stop it, cause it to change direction, cause it to change shape. Now, question is, in what way does the mass of an object impact forces? The answer is the mass of an object impacts forces by affecting how much it accelerates when a force is applied. A larger mass requires a greater force to achieve the same acceleration as a smaller mass due to Newton's second law of motion, that is F is equal to m into A. Who is Isaac Newton? A renowned physician and mathematician from England who discovered in 1687 the correlation between force and motion. Today, his three laws of motion are instrumental in describing the movement of any object in the universe. Newton's first law of motion states an object at rest will stay at rest unless acted on by an unbalanced force. An object in motion will stay in motion at the same speed and in the same direction unless acted on by an unbalanced force. Newton's second law of motion states the acceleration of an object by a force is inversely proportional to the mass of the object and directly proportional to the force. It means force is equal to mass multiplied by acceleration. Newton's third law of motion states for every action there is an equal but opposite reaction. The first one question is, name instance where Newton's first law of motion comes into play. According to the first law of motion, Newton's first law of motion states that an object will remain at rest or continue in uniform motion in a straight line unless acted upon by an external force. This law, often called the law of inertia, can be observed in various everyday situations and phenomena. Here are some instances where Newton's first law comes into play. Number one, when a car comes to a sudden stop, passengers lurch forward because their bodies tend to continue moving forward due to inertia. Even though the car has stopped, objects on a table remain stationary unless a force is applied to move them. For example, a cup will stay put until someone pushes it on or the table moves. Space travel. Objects in space continue to move in their current direction and speed unless influenced by gravitational force or other objects or bodies. Can you think of scenarios where Newton's third law of motion is relevant shortly? The answer is certainly. Newton's third law of motion states that every action there is an equal and opposite reaction. Here are some scenarios where this law is relevant. Number one is walking. When you walk, your foot pushes backward on the ground and the ground pushes forward on your foot. Reaction, propelling you forward. Swimming, as you swim, you push water backward with your arms and legs. This one is action, and the water pushes you forward. Reaction. This one is reaction, allowing you to move through the water. The third point is provide examples when Newton's second law of motion applied shortly. The answer is certainly. Newton's second law of motion states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Mathematically, it can be expressed as F is equal to ma, where F is the force applied to the object and m is the mass of the object and a is the acceleration produced. Here are some examples where Newton's second law of motion applies. Number 1. Car acceleration. The greater the force applied by the engine action, the faster the car acceleration reaction, provided the mass of the car remains constant. Ball thrown. When you throw a ball harder, apply a greater force action. It accelerates further reaction, traveling further and faster through the air. Braking a bicycle. Applying the brakes on the bicycle force. This one is action, causes it to decelerate. Reducing speed. This one is reaction, due to the force opposite its forward motion. Last one is gravity. When an object falls freely due to gravity, its acceleration is approximately 9.8 meter per second square. Downward action, due to the gravitational force. Reaction, regardless of its mass in a vacuum. What is momentum? The measure of an object's resistance to change in its state of motion due to the application of a force. Momentum is equal to mass in motion. Momentum is equal to mass multiplied by velocity. Its mean P is equal to m into v. Conservation of momentum. Conservation of momentum, a scientific principle that states that the total momentum of a system or group of objects remains constant if no external forces act upon it. The principle applies to objects in motion. It is closely related to the Newton's third law of motion, which states that every action there is an equal and opposite reaction. m1 v1 plus m2 v2 is equal to m1 plus m2 into v. Impulse causes a momentum change. Impulse is equal to momentum change. F dot delta T is equal to m dot delta V. When a force is applied to an object, it will result in a change of momentum. This change may involve a shift in velocity, such as an increases or decreases in speed, or a change in direction. What is the definition of acceleration? The change in the speed or direction of an object's movement. Acceleration is equal to change in velocity divided by time. What is inertia? The tendency of an object to resist a change in motion. This means that an object will either stay at rest or continue moving in a straight line at a constant speed. Contact force requires two objects to be in physical contact with one another, typically caused by physical objects, such as when two objects rub against one another, typically localized and affect only the two objects that are in contact. Non-contact force acts upon objects without physical contact, typically caused by energy such as light, sound, and magnetism, can affect multiple objects at once. Objects moved and made to interact with each other through action.